Awesome. Thank you all for coming out today. Really excited to be talking to you about Polygon. Today we're going to be talking about full stack dApp development on Polygon, and specifically how you can kind of use the overall Web3 ecosystem as different building blocks for building out like truly full stack, like robust applications. So a little bit about me. I'm Rahat. I'm a developer relations engineer at Polygon. Previously been a front-end engineer for a while, was a Solidity freelance engineer, and overall been an indie hacker slash Web3 enthusiast. I've tried to build several failed startups. I can tell you everything I did wrong. I cannot tell you how to succeed because I've never done it myself. But you know, I can get you a little bit closer to there and tell you all the wrong things I did. These are some places you can find me. Always happy to chat, happy to go over any kind of like ideas that you have. If you want to bounce any ideas off or have any technical issues, always open to chat about that. So one thing that I kind of noticed as I was going through this specific presentation is that the title of this presentation might not be correct, and I'm not going to give you the title of the presentation just yet. We'll go through that later, but just to keep that in mind, although we're talking about full stack dApp development on Polygon, there is like a bigger kind of underlying message here that we're going to be building towards. So a little bit about Polygon. What is it? So Polygon is the leading platform for Ethereum scaling and infrastructure development. So we provide a whole bunch of different solutions for you to build on top of. L2 solutions, a lot of things on the ZK front that are coming up that I'll be talking a little bit about, as well as folks may already be aware of like our proof of stake blockchain, which is going to be one of the main focuses of our talk today. So calling those out again a little bit right here, proof of stake blockchain again, that's what we're going to be talking about today. One other solution that I really wanted to highlight today, though we're not going to go like fully deep into, is our ZK EVM, which we hope to release later in this quarter on like our testnet. So hopefully you'll be able to start building some test applications on that platform very, very soon. One of my favorite things about the ZK EVM is the fact that everything is EVM compatible. The Solidity that you may already know, that you're already building, will work. All you have to do is just deploy onto the ZK EVM. We did that just to make it easier for folks to like start, coming into the ZK realm, to make it compatible for dev shops who are already building in Solidity, who want to leverage the power of ZK proofs. So I will be talking a little bit more about that at Polygon Connect, so if you're going to be there, I really hope that we have more of a conversation on that there. Before I move on there, just also wanted to call out, like we've got an entire suite of different solutions for scaling. We don't believe in just like a one-size-fits-all solution. There are different solutions for different use cases. So that's kind of what we're aiming for. We're trying to build use cases that make sense for you, for your specific project, for your specific dApp. So what we're aiming to do is build that entire suite so you can pick and choose what is actually useful for you to build out for your users. So building on the proof of stake chain. A few things to keep in mind as you're building on top of it. It is EVM compatible. Meaning you can leverage all of the tools that are currently available to you in the Ethereum ecosystem. If you've already been developing on Ethereum, you already know how to develop on Polygon. There's no difference in different things that you have to learn on like the technical level. All you have to do is switch your RPC endpoint of where you're deploying. Everything else just works one-to-one. A couple of differences, the token, which is the Matic token, all fees and interactions are paid on the blockchain with the Matic token. And rather than ETH, this is how you're kind of like paying those fees. It's accessible, very much like super low fees compared to Ethereum, and sustainable. The POS chain is carbon neutral, and Polygon as a whole is striving to go towards being carbon negative. So here's a little bit about the overall architecture of the proof of stake chain. At the bottom with those nice little purple blocks, you have the Matic sidechain. This is where you will be doing most of your interactions as a developer. This is where your users will be doing most of their interactions, where their wallet is going to be connected to. This is where most of the magic happens, right? You'll see up top, though, that everything is connected to the Ethereum mainnet. Specifically, we refer to the Ethereum mainnet as our root chain. In the middle, we have a layer called the plasma layer. What the plasma layer does is that it has these specific checkpoint nodes that are going to be looking periodically at the state of the Matic sidechain and is going to be saving a hashed value of that to a smart contract that lives on the Ethereum mainnet. So a good way to think about this is like, maybe you're playing a video game, certain parts of the video game, you're saving your state so you can come back to it at a later point in time, right? That's essentially what the plasma checking point is doing. It's saving a hashed value of whatever the current state of the MetaX sidechain is to Ethereum, giving you essentially the ability to inherit some security from Ethereum. Everything is backed up on Ethereum, and transforms this from just being just like the MetaX sidechain into what's called a commit chain. So one thing that I mentioned during that whole spiel there was that POS is accessible. So I wanted to give you a little bit of an example of that. I have a little bit of code up here. This is a very bare bones smart contract on building your own ERC20 token. There's nothing fancy going on here. I believe I copy and pasted this from the Open Zeppelin documentation. So this is just creating a token called Gold Token. In the constructor, it just takes an initial supply for however many tokens you want to mint. Nothing fancy, right? Just mints a bunch of tokens. So a couple of lines, an import from Open Zeppelin. Here is me trying to deploy this using Remix. So Remix is an online IDE for quickly building out your own smart contracts. Once I tried to deploy it in my MetaMask, I see that the cost for me to actually deploy just, 2 or 3 lines of code is $76.42. Same thing now, except I've switched everything over to being on the Polygon mainnet. On Polygon mainnet, now this was about, we'll say a month and a half ago. It's about 0.0029 Matic to send this out. It's like a fraction of a penny. So you're going from 76 bucks to a fraction of a penny to deploy just 3 lines of code, right? So now imagine I'm actually trying to build something in production, an ERC20 token that has more functions, like I want to add things like a tax on transfer. I want to add like an allow list. Maybe this is part of an ICO. Maybe I have an additional contract for like an ICO. The more logic, the more state variables, everything I add, the higher the cost of this smart contract, right? Because storage is expensive. So if I were to go through this very, very quickly becomes expensive, beyond this like $76.42. So that is one of my favorite parts. One of the reasons I actually joined the Polygon team in the first place, when I was first learning about smart contract development myself, it was during the height of like the NFT craze when everyone was just like minting everything and all these gas wars were going on. I wrote a very, very sloppy smart contract. It was like the first one I ever wrote. And I was trying to be a hotshot and like put it out onto mainnet. And when I saw the cost, I said, never mind. So I wanted to go back to this point here. Building robust decentralized applications requires a combination of tools in the ecosystem. So I want to go over a bunch of the tools in the ecosystem that I like using for building out apps. So first, we have just a list of like your developer tools. Smart contract development can be done with a few different things. Hardhat and Truffle are very popular, especially if you come from like a JavaScript background. These are JavaScript-based tools. Brownie is a good framework if you're more of like a Python person. And then Foundry, relatively new, built with Rust, but it allows you to kind of like stick to your Solidity and not really care about anything else. Haven't done Foundry too much. I'm really excited about what that team is doing, so hopefully I'll be able to build a few things in that sense. Some front-end tools that I really like using, WagMe Hooks. Although it's in beta, my personal opinion is it's one of the best tooling for front-end developers in the Web3 space, so definitely check them out. Rainbow Kit, which gives you an awesome UI for just like connecting not only to a MetaMask wallet, but you have to make sure when you're building out your front ends as part of your dApps that you're being as inclusive as possible to as many different users as you can. Rainbow Kit makes that very, very easy because out of the box you're able to connect not only to a MetaMask wallet, you're able to connect to mobile wallets, you're able to connect to Ledger hardware wallets, etc. All kind of like done for you very quickly without a lot of configuration. So Wallet Connect is also a good way to go about things and is one of the underlying parts of Rainbow Kit as well. Ethers.js is what WagMe Hooks is kind of like built around, so I definitely recommend also checking that out. One thing I wanted to touch on, at least for a little bit, is security. We do not talk about security in smart contracts enough. And I mean, over the past, couple days, weeks, you've probably seen some of the messes that, occurred. So it's very, very, very important that you take security seriously when you're building smart contracts. The move fast and break things culture in startup world does not always work in Web3. When you move fast and you break things and you break people's money, people get mad. So it's very, very important to understand what tools are available to you as a developer on the security side of things. Some of the things that I like to use are Slither and Mithril. So Slither is one of my more kind of like favorite ones. It goes to kind of like does an analysis of your code and kind of like flags different potential security vulnerabilities. For example, maybe you have a reentrancy vulnerability in your smart contract when you're withdrawing funds. It'll be able to kind of like let you know, hey, there is potentially a vulnerability here, please look over this code. This alone is not going to be enough. It'll give you an idea of like where you kind of need to go, where you kind of need to look at for your code. But it is important to go beyond this a little bit. And if you're going to be putting something out into production, especially something in the DeFi world, especially something that deals with people's money, to get your smart contracts audited by a third party. Slither will get you kind of like the base of like what you need, get you start thinking on like the security side of things, but it's very important before you go into production, you get things audited. So now I'm going to be talking about specific things that you do inside of your applications to make them a little bit more robust. First, reading data. It's really awesome that I got to go after Cami because I don't really have to explain the graph too much. So everything in Cami just explained about the graph is really helpful for like reading data. No matter what type of application you're building, you're going to need to read some sort of data from the blockchain. Reading data from the blockchain is not the best thing in the world, you don't want to be sitting there writing a whole bunch of like getter functions here and there until you get all the data that you need. The graph makes it super, super easy to like get a lot of that information indexed and sent over to you through a GraphQL API, just like Kenny mentioned right before me. So we'll move into like a little bit of file storage. File storage, there's a couple of different options. Filecoin or IPFS is a really good one, as well as Arweave. I've used Filecoin and IPFS specifically, their Web3 storage and their NFT storage projects. Those are really good, have generous free tiers for just like, putting up, like if you don't even want to like have anything to do with like uploading anything directly from your dApp, you can just like drag and drop, upload assets if you need marketing assets available or anything for like static websites. All of that can be done really quickly through Filecoin using like Web3 storage. Arweave, very similar, has a lot of really cool toolings in that sense. One of my favorite things in the Arweave ecosystem is Bundler. Bundler allows you to upload and keep like storage on the Arweave blockchain without the need for Arweave native tokens. You can even use Bundler and use Matic to actually pay for storage on the Arweave blockchain. So Bundler makes it really easy and accessible to use the Arweave blockchain. Definitely recommend checking that out for your storage needs. One thing I wanted to add on top of the storage side of things is a really cool protocol I've been like looking into called Lit protocol. So they provide decentralized access control for Web3, for apps, private data on the open web. So let's say you have some, some assets that you have put on like Filecoin or on Arweave, and you want to make sure that not everybody has access to it. Lit protocol can actually help you with encrypting it, making sure only specific people, maybe certain allowed users and their addresses can access to it, maybe certain people in specific like NFT groups. Maybe you're trying to make like an NFT gated blog or something like that. Lit protocol is really good for use cases like this and providing that level of access control. So now we kind of go into different like off-chain data protocols. Two of my favorites in this area are Ceramic and ThreadDB. Ceramic is doing a lot of really cool stuff in this sense where you can have like these different data streams and profiles because like not everything needs to be saved on chain. Not everything should be saved on chain, but it should be saved in some type of decentralized manner. So definitely recommend taking a look here. I really like Ceramic because they're also doing things in the sense of like improving on top of like different ways of doing sign-in with Ethereum, identity as well. So check out Ceramic for that type of thing. Now, one thing I wanted to stress is this is not a complete list. There are like tons and tons of protocols out there that are going to help you make it easier to build, actual robust decentralized applications. So definitely check out all of the new things that are kind of like always popping up. It's hard to keep track of things because I feel like every day on Twitter you see this new protocol with this new thing that you can do to add to your app, but you've got to like kind of like vet them to see like what's useful for you, what's useful specifically in the application that you're building. Now, what I want to mention here is like Web3 portals, again, they're your building blocks. It's kind of like how you use them together to build that gets you to that eventual final state of like a full stack decentralized application. But what about the cherry on top? How can we tie everything together? We can use Polygon to supercharge your decentralized applications UX. And I'm going to go into what I mean about that. But I mentioned all these different protocols, all these different building blocks and tools. You can use them all together. You can use them all on top of your dApps that are built on Polygon. I want to show you this tweet from a while back from my friend Dennison. He is working at Tally. And this tweet always it was funny to me at first, but it resonated with me a lot. So he says that the biggest UX fail of Ethereum is gas. I absolutely know why it's necessary. Please, fam, I get it, I know. But regular people absolutely do not get it, they do not care, and they do not want to care. And they quite frankly hate it. So now we're in a bit of a conundrum, right? How do we get regular people who don't care about why you need gas, why you need this level of decentralization to start using your applications? In comes something called gasless meta transactions. So I have a little bit of a diagram here. I'm sorry, I'm not the best person at these diagrams, but I wanted to first kind of like take you through the flow of what a gasless meta transaction would look like. First thing would be doing something, and I'm going to break these down, so there's going to be like further slides on each of these points. But the first thing you do with a gasless meta transaction is you sign a transaction using your wallet. Using EIP 712 with structured signed data, and we're going to break that down a little bit further in a second. You take that signed data, you send it to a relayer, something like OpenZeppelin Defender or Biconomy. That relayer wraps the request into a transaction and sends it to that into the contract, right? But what happened before this relayer received that transaction? You, as a developer, might have loaded up that relayer with some Matic, right, to cover some potential gas fees that your users might incur. That relayer is going to take the inputs from your signed data as well as some loaded up Matic and send that transaction to the contract to be executed on the user's behalf. Now, let's say you're minting an NFT. You have an actual free minting NFT experience with someone who doesn't have to pay anything to mint, someone who doesn't have to pay any gas to mint. You now have the ability to onboard someone who is completely new to Web3 without them having to go to an exchange, buy some Matic, buy some tokens, make sure it's, it's not a good user experience as much as, we like to pretend it is. So let's break this down a little bit further. Signing, EIP 712. This builds off of the concept of don't trust, but verify. We verify that the user has access to their wallet because they're the ones signing specifically this cryptographic signature. You design some data structure on your front end, could be a JSON object or whatever, with specific inputs that, whatever end function is being called needs. If you're using something like Ethers, the implementation is this like signer.sign type data. This is in the Ethers documentation. You can take a look at how to build out this signature using that functionality. And from a JavaScript front end, this creates a signature and makes it ready to be sent to some HTTP endpoint for a relayer. So we're going back to Web 2. You're just sending a request to some endpoint using the relayer. Like I said, we're making an HTTP request to that relayer. Relayers can be loaded with funding for gas. Again, OpenZeppler Defender, Biconomy, Ethereum gas station network, all great options here. And we just make these requests we sign the data, make the request, it executes the contract on our, transaction on our behalf. This is implemented by Lens protocol, and I think this is one of the best examples of like how to use a full, robust, decentralized protocol without paying any gas. Because if you use any of the projects that are built on top of Lens protocol, like Lenster, et cetera, a lot of them are using Lens's GraphQL API. And the GraphQL API that they built uses a relayer. I believe it's on Biconomy. I'm not 100% sure. So that you don't have to pay any gas anytime you like a post, anytime you comment, anytime you make a post or whatever, because all of these things change some state on the blockchain. All of these things, all of these interactions would use some level of gas. But now you don't need to do that. As a user, you don't need to care about that because we have the relayers acting on your behalf in the background. This improves your UX by a very, very large amount. People don't need to care, especially folks who are not native to Web3. Because if we're going to be going for mass adoption, we need to be building our decentralized applications in a way that is inviting to people who don't understand how this kind of works. And you don't have to do this for your entire application. If you think about like how certain software and everything works in the Web 2 world, you have like your 30-day free trials or something like that. That doesn't exist in Web 3. You don't have a free trial. You just have gas fees that you have to pay. Now all of a sudden, you don't have gas fees you have to pay. You can front run and like pay for at least your users at the beginning to like get used to how your applications work. They have a way to actually try your applications in a real production environment without having to spend any of their own money. This is economically viable on Polygon as a chain because of our incredibly low gas fees that I mentioned kind of at the beginning. We're a lot more of an accessible blockchain versus, imagine doing this on Ethereum mainnet, especially when there's like a huge NFT gas war going on, right? So what should the title of this talk actually be? The title of this talk should actually be Building Better User Experiences in Web3 on Polygon. That's what we really care about. We really care about making sure your users are able to benefit from your services, use your applications in a way that benefits you and benefits them. This entire ecosystem is built on folks like you, the builders, and the users who are using your applications. So we're aiming to make sure that the experience is as good as possible, and hopefully what you can take away from this is one way of doing that for your applications. So again, I'm Rahat, Developer Relation Engineer at Polygon. A few places you can find me up here again. Really enjoyed talking to you all today, and thank you.